So I'll try to have these graded by the next class period, and I'll put the scores into MU Online in the gradebook there. You can check any time during the semester to know what your grades are, and so I won't be handing out any printed grade reports through the semester. I make all your grade information available electronically. The next assignment that you have due is on Wednesday of this week, and as a reminder, all the assignments have to be uploaded to MU Online before class begins. Okay, today we're going to be talking about the minimum attractive rate of return. It comes from section 1.9 of your textbook. I'll once again make the plug that you should be reading the book. You know, you paid good money to either rent it or to buy it, and it does an excellent job of providing just maybe another perspective on the material. So coming to class and listening isn't enough to really master this information. You have to do all of the different learning activities like the in-class exercises, completing the homework on your own without any other resources, and reading the textbook. Before we talk about minimum acceptable rate of return, let's revisit the idea of the difference between nominal and effective interest. And I was briefly tempted to put a question related to nominal and effective interest on the quiz, but I wanted to give you a little bit more time for that information to soak in. But there are a couple of trends that I wanted to highlight for you. This is a table that comes from the text, and it's just showing the difference between a nominal rate and the effective rate. And so here in blue are the nominal rates. And by the way, nominal, what does that mean? Not really. So a 6% nominal interest rate isn't really 6% if it's compounded any more frequently than once a year. And so the first point that I wanted to show you is compare the 6% column to the 24% column. And so I've taken the delta between daily compounding and annual compounding. And for 6% interest, the difference between the nominal rate and the maximum effective rate, if you're doing daily compounding, it's not nothing, but 0.18% is a lot smaller than 3.11%, which is the difference between annual compounding and daily compounding for 24%. And so for the first point that I wanted to make is that the difference between nominal and effective is more important the larger the base interest rate is. And so for 1% interest, probably you wouldn't even notice the difference between nominal and effective. But these credit card style interest rates that are really high, the difference becomes quite significant. The other trend that I wanted to point out is that if you look at the difference between let's look at for the 24% column, going from annual to semi-annual. So just compounding one more time per year takes it from 24% to 25.44. And so that difference is 1.44% just by throwing in one additional compounding per year. But then when you go from 2 to 4, you're not adding just one additional compounding period. Now you're adding 2 more beyond where you previously were. But it only increases the effective rate by 0.81%. And so the marginal difference is decreasing. So by the time you get to daily, it's a relatively minor difference between monthly compounding and daily compounding. If we are going to graph that effect, it would be approaching some maximum that even with continuous compounding every second, it's not going to be that much different of an interest rate compared to daily compounding. And so the point is, there are limits to the pain that a bank can inflict on you by compounding more frequently. I apologize. I need to put this thing into silent if I'm going to be giving my phone number out to Indian pharmacies and people threatening me to... Has anybody got the call from the FBI that taxes are due immediately and they want a Walmart gift card for the payment of taxes to the FBI? Yeah. The FBI has been calling me a lot lately, so. All right. Sorry for that. So any questions about this trend? All right, we've seen this figure before having to do with the effect of increasing loan amounts on the interest rate a company would have to pay. And who can refresh our memory why this blue line is going up as the amount increases? Risk. Yeah, if we're going to boil it down to one word, it is that the more a company borrows from a lending institution, the more risky it is that they may not be able to repay it. And so someone who's living beyond their means, you know, the minimum wage job, but somehow has a 5-bedroom house and a really nice car, there's a risk that they may not be able to keep all the plates spinning and that they'll default on the loan. So that's the trend that we talked about in a previous class. Now, think, what if you are helping to manage a company, and that's not too far-fetched. You know, engineers end up in leadership positions quite a lot in companies because they understand quantitative things, they're analytical, and so there's a good chance that some of you may end up in management. So let's say that you're in management and your company has a lot of different potential projects. You know, you have employees who are always proposing new ideas of different things that could be done. And part of this course's purpose is to help you decide from among alternatives. Some alternatives are mutually exclusive, which means you can only pick one thing. But a lot of the time, you can do more than one project at a time. You know, an architect or a software engineer, lots of different companies may have a lot of different projects available to them. And so let's say that we've got these projects that our company could do. Upgrade a computer network, new delivery trucks, remodel the loading docks, and so on. The first step in an analysis and trying to pick which ones should we say yes to and give the thumbs up, which projects should we decline, is to ask how much does each project cost? You know, what's the investment required to get this project off the ground? And then how much is that project going to return? Now, both of these maybe are hypothetical that you have to estimate the cost. Hopefully the cost is a little bit more concrete, but oftentimes the return on investment is just projected. And so you have to always keep that in mind, that there may be a range of possibilities. If someone says, well, if we upgrade the computer network, then our profits will increase 14%, maybe they will, maybe they won't. What you really do is just as a first draft of that analysis is you make your best judgment on what the return on investment will be. And then you order the projects. Now, like I hinted at before, often in quizzes and exams, I'll show you a picture and ask you to explain it. Or I'll ask you to sketch a picture to explain a concept. This is one of the really important images from the semester. So this is one I'd take notes in the margin as we discuss through. It's sorted, project A, furthest on the left, because it's the highest returning project. Whatever this project A, whether it's upgraded computer systems or whatever, we expect it's going to return 35%. So that's the anticipated return of project A. You can see project B is a little less lucrative. It's still a pretty good project. I'd love to have an investment opportunity that paid me 30%, but since it's lower than 35, it's second priority. And so on and so forth. And so they're ordered in terms of highest return on the left, lowest return on the right. Now the width of the bars represents the investment required. And so you'll notice that option A looks like maybe, if each one of these is millions of dollars, option A looks like a $600,000 investment required to do project A. So the width of the bar indicates how much we need to borrow. Because in this illustration, we don't have the money to just pay out of our own pockets. We've maybe been returning profits to investors, and so we need to borrow money for any of these. Project B, the width of that bar represents how much we need to borrow. So it looks like maybe around 1.4 million for project B. Project C, maybe 2.1 million, and so on and so forth. Okay, at the same time that we're ordering all of these projects, what we're doing is we're comparing how much it's going to return to our borrowing costs. So should we do project A? I see some heads shaking yes. I guess that nodding yes. Why should we do project A? How would you explain it? Okay, it's the least cost and the greatest return. So that's part of the way there, but it could still be possible that it's the least cost and the greatest return, but we'd still reject it. So that's necessary, but not sufficient. Why is project A a yes? Okay, well, the risk, the bank thinks that the risk of our default is the lowest, the least amount that we borrow. So it's true that the borrowing costs are the lowest for project A compared to any of the other alternatives. But we still need like a hard and fast rule that tells us if this, then that. Like if some criteria is met, then the project is acceptable.
Well, it meets our minimum attractive rate of return is greater than that, and the rate that we have to pay back the money is much lower, so its rate of return is much higher than the amount of rent that we got to pay on the money.
Okay.
We have set a standard of 16% a year as our minimum attractive rate of return.
All right, so he's got it. The criteria that we say yes or no is the rate of return greater than the borrowing costs? In this illustration, what we're saying is we don't want to borrow money and then earn less than we have to pay to borrow the money. So if you can borrow from someone for 10% and you do something with that money that's going to give you 35%, you should definitely take that deal. Like what if there were two banks? And at bank A, you could go in and take a loan and they'll charge you 10% for the money, and you could step next door and make a deposit in bank B and they'll pay you 35%. You should definitely do that. In fact, you should take as much money from bank A and move it over to bank B as you possibly can, because you get to keep the difference. So this 35%, you get to keep some of it. You have to still pay the privilege of borrowing the money to initiate the project, but the criteria is it's always a yes to these projects as long as the rate of return is greater than the borrowing costs. Now there's a certain point where we reject alternatives. And so if you look, option E is a yes because the rate of return is greater than the borrowing costs. But option F, we could say is a no, because by the time we borrow enough money to do option F, so all the way to, it looks like, a cumulative amount of $6.8 million, we need $6.8 million to do A through E and also F. F isn't our top priority, so we're not going to borrow the money to have it first in line. We want to do all these other higher returning projects before F. But by the time we get enough money to do F, our borrowing costs are equal to F. So there's no sense of doing the project if all of the profits from it will go towards covering the borrowing costs. And we certainly shouldn't do G either, because our borrowing costs exceed the rate of return for G. So when you do an analysis, you need to say whether a project is acceptable or unacceptable, and then you also need to indicate what's the decision criteria. Write down the phrase decision criteria, because it's something I'm going to repeat over and over again. You need to justify your answer. Explain why something is a yes or a no. And F and G are no's because the decision criteria says a project is acceptable if the rate of return is greater than the minimum acceptable rate of return. Okay, any questions about this? Most semesters, someone asks, well, why don't we just reorder it so that G is first? And if G is first, then it would be acceptable because it's taller than the curve is at that point. And the answer is we put G last specifically because it has the lowest rate of return. And so it's not just a graphical problem. The graphical illustration of the decision the company's making, I think, helps you to see why it's a yes or a no, but the answer would still be no even if we made it our first priority. You wouldn't make a project that has a lower rate of return your first priority. So the idea of having them from tallest to smallest would represent the reality that your top priority project should be the one that returns the most. All right. Now, the minimum attractive rate of return is an organization's policy on the lowest value for a project that they're willing to accept. And a lot of factors go into determining the minimum attractive rate of return, and borrowing costs is one of the most important. It's not the only factor, but for a lot of companies, that's kind of the baseline criteria, is how much does it cost us to get the money to do the project. And so here, factor 1 is the weighted average cost of capital. Now, we call it the weighted average cost of capital because there's a variety of different places where we can get money. We can get money from banks. We can get money from issuing stocks, from issuing bonds. The other factors that go into deciding what's your minimum acceptable rate of return is how many good projects are available. And so a company like Apple, since they are kind of like an exclusive brand, they are more selective in the types of projects that they decide to undertake compared to other businesses that sell anything they can to make a profit. The number of good projects available, if you have a lot of good options or if the products that you're selling are exclusive, then you can insist on generally higher minimum attractive rates of return. Opportunity cost is something that we're going to talk about in more detail in a slide here in a minute, but it basically means that when you spend $1 or when you spend your attention on one project, you can't devote that same investment of time or money or attention in another project. And so if you have a lot of good options, you pick the best options, and it may not be constrained just by the funds that are available. Risk is another factor, as well as the cost of administering projects. And some alternatives maybe have a potential rate of return that's greater than the minimum, but it's also possible that they may have a very wide range of possible outcomes. It could be that it returns 15% or it might return 5%. And so that wide range of possible outcomes maybe would eliminate it from consideration. Organization type plays a role because generally governments and large utilities will be able to accept projects that have a lower rate of return than private companies for a variety of reasons. Governments have lower borrowing costs than most companies do, and they focus on the different types of projects. Like putting in a highway, which takes a long time to recoup the investment, even if it's a toll road, compared to short-term investments for companies that are trying to produce profits more quickly. And so organization type, you'll notice that later in the semester we're going to do a chapter where we're focusing exclusively on government projects and how to analyze them. And the interest rates will be much lower when we are discounting to the present for public utilities and for municipalities. So there's a couple of ways that these funds can be raised beyond just going to a bank. One of the options that we haven't talked about so far is called equity financing. And in equity financing, what you're doing is you're selling someone a piece of your company. That's what a stock is. And so if you buy shares in Facebook, you're a part owner of Facebook. And what that entitles you to is a portion of the future profits. That's what you're buying when you buy stock, is you're claiming a share of the profits that are going to occur in the future. And so when a company goes public, as it's called, what they're doing is they're slicing up the company into pieces and taking money for shares of that company, and then they're using the money to either pay off their early investors or to conduct additional research and development or to buy equipment and so on. Debt financing can include bank loans, but it can also include bonds. And we'll, in a future lecture, go through how to calculate bond values. And in debt financing, you're not actually buying a portion of the company. You're not entitled to their future profits. All you're entitled to is the return of principal plus the agreed interest that you commit to at the beginning of the debt financing. And so it's kind of a fixed upside with debt financing, where with equity financing, if the company does really well, you own a fraction of their potentially explosive growth. Regardless of where you get the money, though, the criteria is that a project is economically justified if the rate of return is greater than or equal to the MAR, and the MAR should be greater than the weighted average cost of capital. So how much you spend to get the money. Any questions so far? Okay, I saw this headline a couple of months ago. It said that there's so much demand in the aviation industry, not only for pilots, but even for mechanics, that there are people who can earn $70,000 per year as aircraft technicians. And the article that I saw was actually focusing on a high school in New York City, where people go to this high school and they're learning aircraft maintenance, and as soon as they graduate from high school, they're getting jobs in the $50,000+ a year. And then as they get different federal certifications for working on engines and airframes, they can make even more. More recently, I saw this headline about Walmart. So Walmart's hiring truck drivers for almost $90,000 a year. So I show you these headlines to illustrate the idea of opportunity cost. Your being here today has cost, not only just the tuition that you paid, but you could have been doing something else. You know, whether it's sleeping in, or playing games, or watching television, or if you had a job and you were working at it. The opportunity cost is that you're not able to do the second best option because you're only in one place at a time. So the textbook definition of opportunity cost is either the value of the second best option or the largest rate of return of all projects that were not accepted due to a lack of funds. So as an illustration, let's say that your company has a minimum acceptable rate of return of 10%. You can't do any projects that are under 10. Now, project A, you can't do because you don't have enough money for project A. It has a rate of return of 13%. You are doing project B because it has a better rate of return. So the opportunity cost is the one you couldn't do. It's the largest project that was foregone by funding not be available. Okay, now as I hand out today's in-class exercise, I wanted to show you this formula for the weighted average cost of capital. The last problem in our in-class exercise today asks you to calculate if some company is getting a little bit of money from a bank and a little bit of money by issuing stock and some more money by bond issues, what's the overall average rate of their cost of capital if you're getting it from three different sources that have three different interest rates. So this shows how to do a weighted average. And I'm sure everybody here has done a weighted average before, but maybe it's been a while, so I wanted to put the formula up on the screen. Thank you. Thanks. There you go. So for problem one, I'm curious to know what's your second best option? Like what could you be doing instead of sitting in this classroom today? What are you foregoing to be here? Someone noticed a typo in the notes. I can't believe I haven't noticed it myself. So the formula, that last one should say percent of C in both the numerator and the denominator. So it's the amount of A times the percent of A, amount of B, percent of B, amount of C, percent of C. Sorry for that, and thanks for noticing. So on problem 2, what you're doing is you're comparing how much it's going to cost to borrow the money to the expected return for different projects. So some of those are yes, some of those projects are no. Like delivery vehicles is a yes because 9% return is bigger than the borrowing cost of 2.22%. Since this company is AA, which is kind of a risk rating, then they have to, if they want to borrow money for 5 years, they have to pay 2.22%. And so since 9 is bigger than 2.22, new delivery vehicles is a yes. Updated computer hardware is a no, because to borrow money for 2 years, they have to pay 1.32%, but their project is only going to return 1%. So that project is not attractive because it costs more to borrow the money than you're going to get by undertaking the project. Mm-hmm.
The denominator on the weighted average cost of capital, are we ever going to have a part where we don't have 100%? Like,
It could be amounts. It could be amounts rather than percent. So it could be,
I'm getting $30,000, not a percentage.
yeah.
When,
Okay, well, we are out of time for today. 5.99% is what you should get for that fourth problem. Maybe write it down in the margin in case you weren't able to do all the calculations quite yet. Of course, this solution is on the recording. Let's take one last look at these announcements before we're done for today. The assignment is due Wednesday. If you have any questions, you can stop by during my office hours. I'd be glad to speak to you, or you can send me an email. I'll do my best to respond. We may have some pretty cold weather on Wednesday, so hopefully they don't close the university, right? Wouldn't that be terrible if they closed campus? Yeah, if they do, I'll send out a lecture video for that day, but I think we'll probably be here. We're not going to have the same kind of weather as they're getting in Chicago.